Hello everyone, welcome to another video, and in this video we're going to talk about binary search trees. So what is a binary search tree? A binary search tree is a binary tree where all the left nodes are lesser than their parent node and all the right nodes are larger than their parent nodes. So if any binary tree satisfies this rule, we can call it a binary search tree. So let me explain this on the whiteboard. So let's consider a node 10. Now, if we try to insert 15, what's going to happen is 15 is larger than 10, so it will go to the right of 10. And if we try to insert 5, 5 is lesser than 10, so it will go to the left. Now assume that we're gonna insert another number called 6. The 6 is lesser than 10, so we'll go to the left, and then 6 is larger than 5, so it will go to the right of 5. Same way, if we insert 4, it will go to the left, then it will go to the left of 5. In this side, if we try to insert maybe 20, so 20 is larger than 10, then 20 is larger than 15, so it will go to the right of 15. If we try to insert maybe 14, then 14 is larger than 10, then 14 is smaller than 15, so it will go to the left of 15, and so on. So now you observe that every left node, 4 or 14 or 5, right, are lesser than their parent node. 4 is lesser than 5, 5 is lesser than 10, 14 is lesser than 15. And every right node is larger than their parent. For example, here 6 is larger than 5, 15 is larger than 10, 20 is larger than 15. So any binary tree satisfies this condition. We can call it a binary search tree. So now let's implement the same using JavaScript. So I have created a node, and the node will have our basic structure of every node, right? We'll take a val, and then this dot val equals to val, and then it will have a left and a right node. This dot left equals to null, this dot right equals to null. Then we will have a insert method that will take a value, and here in this method the comparison of the value and the node value will occur. So we're gonna first compare the value and see if it's lesser than the existing parent value. So if val is less than this dot val, and if left exists, because if the val is less than val, we have to push this val to the left. So we have to check if this dot left exists and not null. Then we're gonna call this dot left dot insert method, and we'll pass that value. Same thing we're gonna do to the right side. If val is larger than this dot val and this dot right exists, and then we're gonna push this dot right, push this to right, and so to do that we're gonna call the insert on the right node. then we see that if left and right node does not exist, it means we find a null. We can directly insert the values. So if val is less than, we're gonna put else if, you're gonna put again else if, yeah. If val is less than this dot val, now we can directly put the value. So this dot left equals to new node, and we're gonna put the value. Same thing we're gonna do with the right, else if val is greater than this dot val, and we're gonna put that directly to the right. Right equals to new node, and we're gonna put our value. Simple. So this node is enough to implement our binary tree, but we're gonna create a wrapper so that we can implement our traverse method, so that we can manipulate the values if we need. So yeah, it will have a constructor and it will return, take a value, and it will return a root, new node with the value. Simple. And then we're gonna create a add method that will take an value. It will do nothing but just call the insert on the nodes. So this dot root dot insert and val, and yeah, we just call this insert of the node, and this will take care of our insert, and it will compare the values with the node parent and put it in the right place. Then we're going to create a traverse function. Same thing that we are doing, that always, like we're going to pass a callback, and then we're going to traverse through every node. So let nodes equals to, we're going to create this dot root, and while nodes dot length, we're gonna then shift the nodes. Okay, so let current equals to nodes dot shift. We are doing a queue here, so we're gonna do a level order traversal. So then we're gonna call our method like cb.call, context will be this, and then we're gonna pass our current, and then we're gonna push the nodes to our list. Nodes dot push current dot left, current dot right. Before that, we have to check if current exists. If it's not null, right, then we're gonna do it. Otherwise, it's gonna push nulls to the value and complain. Simple. So that's all. Let's see our test cases. So now I'm gonna go to binary search. So I am creating a BST, or binary search tree. I'm calling the same class, instantiating the same class and passing value 10. So our root node will become 10. Then I'll be adding 5. 5 is less than 10, so our left value should be 5. And if I add 15, 15 is larger than 10, so it will go to the right, and right will become 15. If I add 4, then 4 is lesser than 10, then 4 is lesser than 5, so 4 will become left of 5. And if I insert 6, 6 will become right of 5. Same way, if I insert 11, 11 is lesser than 15, so it will become left of 15, and 16 is larger than 15, so it will become right of 15. So yeah, then I am calling the trav method, and I'm multiplying every value with 100. So our root value will become 1000. It was 10 before, now it should become 1000. So let's run our test cases. So let's see what happening. It's not finding the right value. So val is less than val, left exists, we are inserting left. If val is greater than this dot val or parent node, if right exists, here is the issue. We are not inserting the value. This should work now. Let's see. Passed. So this is how we're gonna implement a binary search tree. So thank you for watching.